screen? I can see my PPT.
Yes, sir. Visible.
Yeah.
We'll wait, sir. 5 minutes.
No problem. No problem.
Participants joining.
Not an issue. I'll just unshare for now. So just one thing in the introduction when you introduce, right? If you could just mention that I've been working with around 125 colleges.
It is
I
there,
think
sir, in your
it
resume.
is 65 plus I mentioned, but I have
Okay.
not revised the numbers, so you can just mention 100 plus also is fine. That's fine.
Manas, please remind it.
Okay,
Manas,
sir. Okay.
note it. 100 plus instead of 65, you mention 100 plus.
Okay, sir. Okay.
Thank you.
Manas, you also check. Sometimes I am forgetting to recording. Okay.
Okay, sir. Sir, attendance.
Attendance started tracking.
Okay, sir. Okay.
Sir, how many participants joined yesterday?
Around 150 is there, sir.
Oh, very good. Good count.
Sir is ready to handle any requirement is there in future. If any resource person not ready, and to remaining days. Remaining 3 days, if any resource person is not ready, sir is willing to take sessions. Arrange it, sir.
Yes, sir, I'm there. I'm available. Yes, sir. So because today in supervised learning, I cannot cover everything.
No problem.
I
Whatever
will
is
cover only part
possible.
of it. So if I get another opportunity, I'll be happy to help you out and cover
Yeah. If any chance is there, are you ready, sir? Remaining 3 days.
Yes, no problem.
Okay. We'll inform.
Just give
sir.
me a day's notice, sir, so that I can plan.
We'll inform, sir, if any chance is there.
Okay.
I will inform.
But I'm surprised, sir. I've seen you in video, but okay, you must have not have seen it. So probably I must have forgotten last time. Sorry about that.
Yeah.
Know. Maybe some reasons. Because generally my video is always on.
Last time
you
you started from mobile last time.
So because of some network issue, I don't remember.
Yes.
My memory is very bad. Sorry about that.
Good morning to all and warm welcome to second day of faculty development program on data sciences organizing by Department of Computer Science sponsored by ATAL Academy. So today we will start the second day's first session. I welcome Manas Rahman, research scholar, to introduce the today's resource person. Manas.
Thank you, sir. Good morning, one and all. It is my pleasure to introduce our resource person today, Mr. Arunjit Chowdhury, CEO, Enterprise Building Training Solutions. He has 20 years of experience in handling various technology projects across Asia, Pacific, USA, and Europe. And he also worked in different capacities, including project manager, quality manager, program manager, and key delivery manager. Also, he worked across various industries in manufacturing, defense, banking, and CPG. He also proven the ability in managing, building, implementing complex enterprise level programs for projects globally. And he have a great passion for teaching and have taught students across 100 plus colleges in the areas of SAP, machine learning, and other emerging technologies. So it is your turn to utilize such an eminent personality and grab the knowledge from him. So without any delay, I would like to invite Sir Arunjit Chowdhury to start the session. Sir, please.
Thank you, sir. Thanks for the nice introduction and welcome to everybody. I just want to do a few things while I'm sharing my screen. Where is the chat? Okay. We have the chat here, and I'll just open the presentation. Okay. Okay. I hope my screen is visible, and I keep the chat on the side so that while you ask questions, I can also see those questions and try to answer. Okay. So, good morning to one and all. And before I start, just few things I would like to highlight here. Uh, I would like all of you to please participate in this session that I'm going to get into. And the more the participation, the more the engaging the session is, and the more the interesting the session becomes. And because that's my way of teaching, and because I've also always feel that as much as whatever little I know, I can get a lot of information and a lot of knowledge can be disseminated within the group across various faculties who come from different colleges, institutes, and with different capacities. So please take this occasion to one is learn whatever little I can teach you, and but at the same time, please share your knowledge so that it will be useful for me also and also for the others, right? And as far as possible, try to unmute and speak. That will help me. And I'll be also asking a lot of questions also in between so that I get an insight of your understanding of what we are doing today. And today's topic is going to be on machine learning. I mean, obviously, on the first 2 days, you had an introduction of data science and some topics around that. But today we'll have the first topic on machine learning, and my focus is going to be on supervised model. While I'll try to cover as much as possible, but I'll try to in that 1.5 hours, and I'm going to show you some hands-on scripts also, so that you can see how it executes in Python. Many of you may not be technical, does not matter. I'm not going to get through the code, but at the same time, I will make you understand what is the implication of the code or what is the net result. And at the end of the session, I will share with Kumar sir this PPT as well as the code and the scripts, so that you guys can practice as per your convenience, and so you can try it out. Great. So before I start, I just wanted to understand from you, any of you guys, what is your interpretation of machine learning? Anybody? Yes, please. Anybody?
Yes, participants can respond. You can
Collection of
unmute.
tools to minimize repeatability of writing a code. Okay.
Sir, it is a study of the computer algorithm and can improve the automatically through experience by the use of the data.
Can you be a bit loud, ma'am? Sorry, I didn't hear you. Can you come closer to the mic?
Can you hear me, sir?
Yeah. Can you repeat again, please? Sorry, I missed you.
Sir, it has a computer algorithm and by which we can improve automatically through experience and by the use of the data. That is a machine algorithm. Sorry, there is a machine learning.
Learning through experience. Very good. I wanted to hear this word, learning through experience. Very good. Okay, what else? Anybody? Please omit my spelling mistakes. Okay, let's focus on the content than the spellings. Okay, next, anybody? Computer algorithms to automate the processes. Okay. So what do you mean by automating? I mean, ultimately, when I'm talking, what is the net outcome of learning through experience? You learn this word, learning through experience, algorithms, and then what is the net outcome? What is the net out? What do you want to derive out of that?
So good morning, sir. So myself Swati.
Yes, okay.
Yes, sir. So basically, through the automation, we can allow the computers to make the decisions just like human beings. They can predict the data. They can predict what can be done for this
So
in the near
very good
future.
word. You used the word prediction.
Yes.
So prediction on based on what?
So prediction based on the training. We have data sets. We train our computers accordingly. We train the systems, and accordingly they give us the predictions that this can be the future of this.
But on what basis it has predicted?
On the past data. Prediction based on the past data.
Correct. But what it is trying to derive? So what I wanted to get that
relationship.
Word is absolute pattern.
Pattern.
Or the pattern. Yes, this word is very important. I want to derive a pattern out of the data.
Yes.
Only if I can derive a pattern out of data, I can predict for future data. Correct? Or any new set of data. So what I wanted to hear was the very nice. So we talked about how to derive a pattern between the various data in the data set. Okay. And based on the pattern, you predict the output, prediction of the output. And this prediction should be close to the actual data. Yeah, you can say a model is effective if your predicted data is matching the actual data, right? In that case, you don't really require to do your actual. So that's where you use the model to try a new set of data, and it will give you the output result on its own, right? So should be close to the actual data. Okay. So this is all we talk about machine learning. Okay. Now, what is the difference between machine learning and expert systems? Has anybody heard of expert systems?
Yes, sir. For expert systems, we have a knowledge base in place.
Okay.
And we only use that knowledge base to take the decisions.
Give me an example.
For example, if I have a washing machine, so we have a knowledge base already in place, and then it will use only the existing knowledge base to make the decisions. Like if the temperature is low, then you need to heat the water and decisions like that.
Okay, good. So, I mean, that's a good example. I mean, I generally take an example of a healthcare, which is very common, right? It's easy to correlate, to relate better. So, for example, when you have a symptoms, you go to a doctor, the doctor gives you, there's a diagnosis, he will ask you to do some tests. Based on the test, he will tell you this is your disease or this is the problem you have, and then he will give you a prescription, right? So, all these can be captured in the form of a business rule, right? And this business rule you can program it using any programming tool, and then using the prediction mechanism or using the tool, you will be able to predict sort of a prescription based on the particular disease or a particular symptom. So obviously here you have hard coded the rule. Your pattern is known. Your rule is already known in advance. But the problem is you have to do a lot of coding. You have to capture all the business rules so that it gives you an accurate prediction. But this becomes a tedious process, or it becomes a disadvantage when your business rules changes, right? So tomorrow some new symptom will come, or a new prescription will come, new diagnosis test will come. So again, you have to go on changing. So you actually do what is called an explicit programming in the case of expert systems. But when you come to machine learning, in machine learning, there are already algorithms written which help you to derive a pattern between an input and an output. Now, why I'm talking of input and output is basically I'm going to talk specifically from a supervised model perspective. So you have an output and an input, and then you have to predict, or you have to find out the pattern between the output and the input by training the data using the algorithms. So in the case of machine learning, you don't have to do explicit programming, while here in the expert systems, you have to do something called an explicit programming. Okay. Now, how many of you have heard of deep learning?
Excuse me, sir, I have one. No, I just want to clarify.
Sure.
So can I say that in expert systems, the knowledge base is fixed, while in case of machine learning, the uh, system keeps on improving itself?
Perfect. Perfect.
Yes, so I can say this.
Perfect. In fact, if I say my accuracy from an expert system will be close to 100%.
Okay.
But if you ask a machine learning algorithm, it will never give you 100% accuracy.
Okay.
It is very difficult. I mean, you write the best of the algorithm, even if you get 95, 98% accuracy, is still good. And today in the industry, even if I get an accuracy of 90% plus, I'm good to recommend that model to my customer.
Okay. Thank you.
Okay, you will never get 100% accuracy when it comes to machine learning, right? Has anybody heard of deep learning? Have anybody heard of neural networks?
Yes, sir.
Yes, sir. Yes, sir.
So why this has become so important? Why is it so important? Anybody?
It's like in applications where huge amounts of data is there. So deep learning networks perform better as compared to machine learning algorithms.
Yeah, so one is obviously the complexity of the data, and especially when the data is non-linear.
Yes.
Okay.
Yes.
That's where it becomes very important. And as one rightly said, when you want to do image detection, okay, non-text, okay, could be audio, could be video, could be images. That is where you need neural networks, right? Third, very important, is sentence sequencing. What is called, okay, for image classification, we use what is called the CNN. It is called the convolutional neural networks. Okay, you have what is called ANN, as somebody rightly said,
Artificial neural networks.
Yes, Jagdish has said, right? It is called ANN, artificial neural networks. Okay, there are a lot of layers and all that. There's a different concept by altogether. It's also a very interesting thing. But yes, you have ANN, CNN, and sentence sequencing, or if you see the chatbot,
Okay.
which you see in your website, right? Okay, that is an example of a recurrent neural network. Yeah. So this is called RNN. So you got ANN, CNN, and RNN, and so these have also become very, very popular because of the complexity of the data, the type of data. Okay, so deep learning is the next stage, or you can call it the next level of machine learning. Have you heard what is called RPA? Anybody has heard of RPA?
Robotic process automation.
Very good. So what does it mean? What is
Actually, it is
process
also
automation
it will also automate some basic mundane tasks. We
It will
can
automate
automate.
some basic business tasks. Very good. For example,
Sir, if I'm keep on getting mails from particular person on daily basis, 50 or more mails, then I can collect them and I can store them in a particular drive or directory, whichever I want.
Can you give me an industry example?
Industry example. I'm not much familiar.
No
Because
problem. Anybody else? That's fine.
basic mundane task we can
Mundane
use.
task, you're absolutely right. Absolutely right. Mundane task. So let me give an example. See, there is something called a business process in any organization. Okay. When I say business process is a sequence of steps which you do to arrive at a net result. For example, today I go to Big Bazaar, or if I go to Hindustan Levers is a company and I am a customer. So when I go to Hindustan Levers, and Hindustan Levers, obviously they will sell through retailers or wholesale and all that. So the way it happens that when I want to buy a product, okay, what I will do is I will first raise a purchase order. I will raise a purchase order, give it to my customer. Customer, based on the purchase order, he will deliver me the product based on the schedule. Okay, because depending on how much stock he has, he will deliver the product. Once he delivers the product, then the customer will raise an invoice or a bill to the customer. So the company will raise an invoice to the customer, and then the customer will make a payment to the company, to Hindustan Levers. This process is called order to cash. If anybody have heard of ERP systems like SAP, Oracle, they all talk about business process, and all these business process, some of these tasks in a business process can be repetitive. Okay, so you can automate the complete process. Okay, so that is where you use something called a robotic process. So it's basically automating a business process. I am just looking at the word called the business process, right? So you have tools like the Automation Anywhere, you have Prism, there are various other tools which are there which takes care of robotic process automation. So this is how AI has evolved, right from expert systems, machine learning, RPA, deep learning. Okay. And obviously you have NLP, which is in a very big area which is coming, where you're talking about, again, sequencing of sentences. If you see any email, Gmail, when you write a Gmail, on the bottom C, it will give you some responses. Yes, or yes, I acknowledge the mail, or no, I don't acknowledge the mail, or something like that. Now, these responses are based on the text that you write as part of your initial message. So this is called sentence sequencing, which is again as part of the recurrent neural network. So this is a very interesting technology which is happening today. So any questions on this, how neural networks or how AI has evolved? Is this clear to all of you? Okay. Now, having discussed all this, really don't worry, I'll be sending all this to all of you. Now, I'm going to talk to you about, anybody can tell me what is supervised learning? I'm sure a lot of people must be aware. Anybody who knows what is supervised learning?
To train a system with the past data.
With a fast data. No, but you're training a system even for any unsupervised learning also, no? What is the difference?
We are knowing the
Similar
classes of
pattern.
Sorry, what did you say? I heard a good word. Yeah, please.
classes are
Similar
known when
pattern.
Similar pattern. What do you mean by similar pattern?
Supervised machine learning, sir.
When-
We have the excuse me, sir. Can I?
Yeah, please. Yeah.
Supervised machine learning, sir. We have set of data. With the help of that data that is labeled, we train the machine, and from that training, it is getting trained. And whenever he want to do any activity, he from that data only do the activity. Once we have feed the data, suppose he has to do a task of going from one place to another. So that data we have filled, and that data is labeled. From that data he has learned and trained. So in supervised machine learning, from this labeled data, he does all the work and keeps on learning from that appropriate data. Or if we talk about machine learning, we have a set of algorithms which we for different types of predictions and different types of activities we do. So we put all those data in that machine learning algorithm, And when we put all those algorithm in machine learning model, so from that algorithm, that model runs, and the prediction and training, whatever testing we want to do, that is done.
So what comprises the supervised data? Do you have an input? Do you have an output, or you have only inputs?
Yes, definitely we have an input that whatever input or whatever data we have, from that data, whatever useful data we can extract, that is known to us, labeled to us, that we extract and run the model. In simple words, sir.
Correct. As somebody else was also saying something. Sorry, ma'am.
Yes, sir.
Yeah. What were you saying?
So when the class labels are known, then we are doing supervised learning.
What do you mean by class labels are known?
Known means if we know, then we know that in which classes our data is going to categorize.
You're talking about only a specific case of supervised model.
Yeah.
Maybe you're talking about classification, but in general, what does a supervised model mean? In a supervised model, always remember, in a supervised model, you already know the pattern of the data. So you will always have an output. You could have multiple inputs. Right? For example, if I'm taking a simple example of y equal to m1 x1, x1 plus m2 x2, and so on. So my y is my output, x is my input, right? I could have multiple x, but I will have only one y. Now, what is this y called in machine learning language? What is it called? Anybody?
It's a slope.
No, y.
Okay, y.
M is the slope.
Yeah.
It is called dependent variable.
Okay.
Right? Y is called output, or it is also called a dependent variable. X is called, of course, independent variable. Any other term we use called a feature. We also called a predictor. Okay, so you could have, so in a supervised learning, you have a situation where when I say labeled means you will have a specific value. When you talk about labeled data, it generally comes about a classification. I'll come to that. So you have multiple inputs, but you have one output, and you know the pattern of the data in advance. Okay. Now, when you talk of regression, there are two types. One is the supervised model. One is the regression. What is regression? If I look at this equation, what is regression? Why is it called regression?
Sir, we have multiple data sets. If we have, if in a XY coordinates, we have a multiple data sets, and we want to fit the best fit line that is passing through the data. So that is called regression, sir.
No, regression is maybe a straight line as y equal to mx. Okay, but
Yeah.
why this is called a regression line? When you call
Because
it a regression,
the independent variables decide the dependent variable. So if we know the independent variable, we can easily predict the dependent variable.
That is irrespective of whether it's a regression or classification. So what is so different between regression and classification?
Sir, may I?
Please.
Yeah. Sir, in regression, we predict the future behavior based on the past. And in classification, we categorize the data into different classes based on the similarity of features or attributes.
So that anyway you will have an output. No, I mean you will predict the output.
May I add something?
Yes.
Yes.
Yeah. So basically, regression is for predicting a continuous quantity, you can say.
Correct. That's what I'm looking at. So
For
in the
classification,
case
is
of
a
regression, your y is continuous. It's a continuous variable. It changes with x. Okay. So whenever your x changes, your y changes. For example, I say that the price of a house, which is my dependent variable depends on various factors. It could be the square feet, the floor in which it is in, the area where it is located, how proximity it is to the malls or the theaters. That will decide the price of a house. So in this case, the price of a house will differ depending on all these parameters. It is not a fixed value. That's why it is called a continuous variable, right? While in the classification, your y is discrete.
Discrete.
That means it will have a fixed set of values. Either yes or no, or a guy is having cancer or not having a cancer, or a guy wants to buy a car or doesn't buy a car. So it becomes a discrete labeled fixed set of values. So this is the main difference between a regression and a classification, right? Now within regression also you will have a univariate regression where you have a single independent variable, or a multivariate regression where I talked about the price of a house, a classical case of multivariate regression where the price of a house is a dependent variable and your area, the number of rooms, the proximity all becomes your features or the independent variables. So this becomes an example of a regression, a multivariate regression. And classification, as I said, it could be a discrete set of values. And today classification problems are much more important than regression. I mean, regression is also equally important, but in my today's topic, because of the time, I'll be focusing more on the classification. Okay, but I just wanted to get introduce of this concept. What is unsupervised model? Anybody?
Sir, in unsupervised machine learning, we don't have any labeled
Sorry,
set of data.
Okay, that's fine. What? Yes, it's not labeled
Sir,
perfect.
in that, what happens from the experience, the machine learns. If suppose there are some things, if we talk about he's having, if we have 4 persons which is having different ages, different body weight, and different height, so these factors will be predicted. The machine that this is make a cluster of ages, height, and weight. So this will be, sir, which is not labeled, but from this he is predicting and getting the data and learning that this could be like this, in which things are not defined, well defined.
Correct. So I think you mentioned right the word for clustering.
Of things,
right? Yeah. So basically, as in unsupervised, the main context is you don't know the pattern of the data. You don't have an output. You don't have an input.
Yes.
You have series of inputs, but you don't have a predicted output, right? And you want to try to derive a pattern out of the data. And that's where you use clustering to basically group the data on a particular attribute. It could be the age of a person, or it could be anything. Like I simply talk about a very nice example which I gave in all my classes is a mall. And in the mall, you have various customers coming in, and the owner of the mall wants to come out with a marketing strategy or an advertising strategy. Okay, for that he's going to collect various information about the customer. He will capture his age, salary, and say something called a spending power. Now, what is a spending power? This is something which you can derive from some formula where the mall owner, basically depending on how much he's spending, some formula he will say, okay, high spending power or medium spending power or low spending power. So typically, if the scoring is say between 80 to 100 is a high spending power, the guy likes to spend a lot. He tries to try out new products. A guy between 40 and 80 could be somebody who is a moderate guy, and a guy between 0 and 40 could be a sort of a guy who doesn't spend much. He's very cautious. Okay, it's sort of a thrifty guy, right? He doesn't spend much. Now, so what I can do is I can group this customer. I can, based on my problem statement, I can group my customers into 2 categories. I mean, I could have maybe high salary, high spending power, then high salary, low spending power, right? And similarly, maybe I could have low salary, high spending power. Okay, that also maybe could be interesting for me because a lot of people They spend their low salary, but they like to take a lot of things by credit card, or they like to spend a lot, right? And then based on the categorization, then I can come out with an analysis as to how much of percentage are coming, people are coming in each of these categories, and this is called grouping or clustering. And then based on that, I can take a mall owner that if I get high salary, high spending power is around 30%, then those 30% audience I can focus on creating or introducing new products in the mall, or introducing new product lines in the mall. If I have a high salary, low spending power, I can have a strategy where I can give him a sort of a promotion where buy one get one free, something like that, or buy one get a discount of second of 10%, 15%, whatever. So I could come out with, I can formulate different strategies based on this categorization that I've done and the outcome that I get based on this grouping or clustering. That's basically what is called a unsupervised model. Okay. And obviously the third type is called a reinforcement learning. And this is a classical example of your robotics, right? Your robotics, is works on the concept of reinforcement learning. As it learns, okay, there's a concept called, it's a very, very interesting topic. It calls about a state, it takes an action, there's an environment, as it moves from one state to another. So there is something called a reward. So whenever it learns by itself and takes a desired, it moves from one state to the other using an action. If it goes in the desired state, then it gets a reward of +1. And if it doesn't go to the desired targets state, then it gets a reward of -1. So the object of reinforcement learning is how do you maximize the rewards? Okay, means you maximize the reward so that that is what is the objective of reinforcement learning. So that's a different topic altogether, and there are various things like Q learning, and there are various algorithms which are available which does all this. So these are the three classic types: supervised, unsupervised, and reinforcement learning, right? Now, I want to talk to you about a model workflow, and I'm going to execute some few scripts. But before that, I wanted you guys to understand, especially from a supervised model perspective, how does a flow happen? Now, suppose I'm the HR manager of a company, and I want to come out with a machine learning model, and I'm a data scientist. So the customer comes to me and tells me, comes out the models. He has given me very simple data. He gives me a years of experience of my customer, of my employee, sorry, and the salary of my employee. So these are data I've got, and the customer comes to me as a data scientist, and he wants to come out with a machine learning model. So whenever I get such sort of data, typically the data will never be perfectly correct. There'll be some problems. Either there'll be some null data, there'll be some data missing, there'll be some there is some data which is not in range, what are called the outliers. Okay, and for example, I cannot have a years of experience of 70, right? Doesn't make sense. Neither I can have a salary of say 100 rupees. Okay, I'm talking normal employee companies, right? So those many situations come, and then you will have to do what is called a data pre-processing. So data pre-processing becomes a very important step before you actually get into the training. And once you do the data pre-processing, like you have some missing data, you have to take care of missing data. You have some null data, you should take care of null data. So let me ask you one. If you are a data scientist and you get some data which is missing, say for example, you have a years of experience missing for a particular salary, what will you do?
Sir, first of all, we check whatever the data is missing by applying the commands. Then whatever is missing, that we have to fill in those parameters of data set, because else it will be not
How will you
executed
fill?
properly.
How will you fill it up? You don't have the data. How will you fill it up?
But
Jagdish talks about
data.
interpolation, imputation. Okay.
We will compare the salary with some other people.
Compare the salary with
Because
some other
if
people.
because without giving the input, we can't have the desired or predicted output. If we have any data, so we will assume some.
You can use the average salary.
See, this is the mistake we all do as data scientists. Okay, and if I have been in your place, I would have also done the same thing. But this is the first thing you should never do. Is data interpolation, extrapolation, whatever you talk. See, please remember, who is the owner of the data? It's not you as a data scientist. It's the customer. If the customer does not give you data, you have to go back to the customer and ask for the data. This is a part of the data preparation phase of a life cycle of a data science project, where you have to, as part of data preparation phase, where you do a lot of data cleaning, data inquiries, then you have to do data analysis. You have to make sure if there is some data to be cleaned, you have to get the data, right data from the client. You will do an interpolation, extrapolation if the client says that I don't have the data with me. In that case, I will do some, maybe I will take the mean of some other data, I will do some median, or whatever, I can use different formulas. Or I can write my own function. But my first and foremost thing is to how do I get the data is I have to go to my client and make him responsible. Because data responsibility is not yours. Data responsibility is with the client. So you have to go back to the client and ask for the right data. And if the worst scenario client doesn't give you the data, then yes, then you can write your own function, and then whatever function or you're going to do, you need to get your concurrence with the client. Other client will not sign your data preparation phase. Every phase has to be signed off by the client. Okay, so you have to make sure this is very important. So you need to make sure that, and the last thing you should always remember, the last thing you should ever do is to delete the data. Because if you delete data, you will have less amount of data for training. Okay, so you should always ensure or make sure that the deletion is taken as the last option. Okay. Now, once you have done all that, then you also have to do is a splitting the data into a training set and a test set. And test set into training and test set. And typically, and we all know, I mean, why do we do training? Is that we train the records, and for testing is to test the efficiency of the model. To test the accuracy of the model, we use test set. And typically, the ratio is minimum 70% should be training. So there is no rule, but I've generally seen in the industry, minimum 70% should be training, minimum. Okay, you could have more, but minimum 70% and max 30% should be test. So typically you could have 75-25, 80-20, 85-15 also, depending on the volume of the data you have, but you should typically should not be less than 70%. Now, once you have done the data training, data cleaning and data split, okay, then what I do is, suppose I've got, in this case, I've got 1000 records. I've got from a client. I've done the cleaning, and I say 700 records is training data and 300 records is test data. So what I do is that I take the training set, that is, I take the independent variable and the dependent variable of the training set and run the algorithm and try to derive a pattern. Now see, what I do now, what I'm doing now is, once I've trained the model has come out with a pattern. I feed the independent variable or variables into the model, and I come out with a predicted output or a predicted dependent variable. And then I compare the predicted value with the actual value. This is where you have metrics to measure the accuracy of the model. And if your metrics gives you an accuracy of at least 90%, then I can say I can recommend this model to my client. Is this workflow clear to all?
So one question.
Sir, I want to ask one question. Sir, you said that you have divided 70% for training and 30% for test data. But while explaining the things, you said that you have trained your model with training data only. And then you have prepared your model for the predictions. So where that 30% test data goes?
So from this model that we have predicted, right?
Yeah.
So what I do is that, okay, now what I do, these are my 300 records.
Yeah.
Where I'm feeding only my independent variables.
Okay.
To the model. And then I'm getting a predicted dependent value for the 300 records.
Okay.
And you already have the actual value for the 300 records.
Yeah.
Then I compare the actual and predicted.
Okay.
So if my predicted value, because predicted value comes out of the model when after you got trained, after the model was trained, it has come out with some pattern. Then you get a predicted value feeding the input variable, independent variable, and then you get a predicted dependent variable and you compare it with the actual. Then you have a predicted salary and you measure and you compare it with the actual salary.
Okay, then when some new values will come, then we can use those new values for
you can
further
use this
predictions.
model to predict the future values, because now with the existing test data, you are able to get an accuracy of 90%.
Yeah.
So I can say confidently to my client that please use this model for this particular set of data.
Okay, thank you, sir.
And Jagdish was talking about validation data set. There are occasions where people do 70% training, then there are some 10% of validation and 20% of testing. Now, why this validation is done is basically to take care of overfitting.
Yes.
Okay, so you have to validate the data, use it to basically take care of overfitting. Now, when you talk of overfitting, essentially what it means is that it typically gives you very good high accuracy for training data, but it gives you very wrong output for test data. So training errors are less, but the test errors are more. So validation data set is one way of testing the overfitting before you use the testing data set. Okay, so that is where I think there was a question asked about the validation data, but it is used in many scenarios. But it depends on, again, from case to case. But yes, you could have a combination of training, validation, and a test data set, right?
So one more question I just want to ask.
Yeah.
So how this split is performed, like 70% and 30%? How the splitting is done?
So there is a function available in Python. I will show you that.
Okay. So this it will take randomly 700 records from this.
There is a algorithm. There is a function where you can have a random state as a parameter.
Okay, sir.
Which decides, it creates a random number, and either you can do it in sequence or you can do it random.
Okay.
There's something called a random state. When I come to the script, I'll show you. But is this workflow clear to all?
Can I ask one more
question?
Please
go ahead. Yeah, please.
Sorry, can we, is there any perfect division, like 70% or 30% or something else also?
No, it's nothing. We can try with 75-25 also. That's not an issue. Okay.
50-50
if you ask me, I will. Sorry.
50-50 also can we take?
No, it's not, because if you should have more of training, na. More the training, better and the better the model will come out with a pattern.
Okay, sir. Thank you.
You can never have a testing more than training.
That
is never possible, and you cannot have zero testing also. You need to have a test data also, right?
Okay, sir.
Is this workflow clear to all?
Yes, sir.
Yes.
Okay.
Yes,
So
sir.
let me go to Python. Now, I will show you some data pre-processing steps, which I talked to you about, and then I will actually run a model on classification called the logistic regression. Okay. So I've got, this is my Spider Python. Now, this is, how many of you have worked on Python? Spider?
Sir,
Have you guys worked
Sir,
on
I have
Spider and
worked.
Python?
Yes,
not
sir.
on Spider, sir. We have worked in Jupyter and PyCharm.
Okay, a lot of people have worked on PyTorch, a lot of people have worked on MATLAB, a lot of people work on Jupyter Notebook, and this is also Python. So typically, if you use Anaconda Navigator, which is one of the open source tools which you
Yes,
download,
sir.
you will get Spider, you will get Jupyter Notebook,
Yes,
and
sir.
if people are using R, you will also get R Studio. Okay, so these are the various tools which are available as part of the Anaconda Navigator tool set. Now this is the Spider Notes Python I've installed, and what I see on the left hand side is where all my code I write.
Yes, sir.
On the top right hand side are the files which I'm going to execute. There's something called a variable explorer where when I output any command and I assign it to a variable, I can see the output here. And I got a help if I want to do a help from any tutorials. It has got an online tutorial. Okay. And this is the console. Whenever I
Sir,
execute something from, yeah, sorry.
so is it possible to increase the font so one can read it here easily?
Yeah, let me just, I think that should be possible. Control plus.
Yes. Yes, sir. It's good now.
I think, okay. So
Thank you,
whatever
sir.
you execute on the left hand side, you will actually see it it will execute on the right and it will show the output here. This is called the console. So it will show prompt 1, and then once it is successful or if there's error, it will give you the error message and then go to prompt 2, then you'll execute the next line and so on, right? This is how the Python interface looks. And I'm going to open a file called data pre-processing template. Okay. Now there is a file called data.csv. Let me open that file. And it has got 4 fields: country, age, salary, and purchased. What it means? I am an automotive company. I am doing a survey of my customers, whether they're going to buy a particular brand of my car or not. So I capture the country he belongs, I capture his age, his salary, and whether he's purchasing a car or not. And I need to come out with a model to predict the possibility of a person buying my car, my brand of car or not. Now, with this data, can you tell me whether this is a classification data or a regression data?
Regression data, sir.
Why is it
No,
regression
sir,
data?
it's a classification
Classification.
data because it is giving
Oh,
results in the form of binary classification, whether the person purchased or not, yes or no.
Very good. So, which is your independent variable?
prediction.
Which is your independent variable?
So,
Country,
independent
age,
variables are
salary.
country, age, salary, and
Correct.
purchased is dependent.
Very good. So, your country, age, and salary becomes your independent variables, and your purchase becomes your dependent variable. Okay, very good. So, now what I'm going to do is, this is my existing script. So, those who are technical will understand, those who are not technical, don't worry. So first of all, what I need to do is I need to import some important libraries. I'm using Python as my programming language here, programming platform. So I'm going to import some few libraries. There are 3 important libraries. One is called the NumPy, which is mainly used for numeric calculations. You have matplotlib, which is mainly for graphical representation. And the third is pandas, which is mainly for data manipulation. So whatever data you're going to import, data set you're going to read, you will have to use the pandas library. So what I'm going to do now is I'm going to either I can select all the lines and execute together, but for now, just for everybody's convenience, I will select one line at a time. So I will select the line and say control and enter. It gets executed on the right hand side. I execute the second line, I execute the third line. So I've imported my main libraries, which I use for my script. Sorry. Then I import my data set. My data set is my CSV file. And in this CSV file, this is why if I go to Value Explorer, I am able to see my CSV file. And in this CSV file, I have got country, age, salary, and purchased. Now, do you have any problem with this data?
Yes, sir.
You have a problem.
Yes, sir. For the
Two
age
places there is
and salary
NN.
is missing.
So what you will do?
Pre-process the data.
So what will you do?
We will replace some value there.
You will replace the value. Again, I think we're all, I've emphasized so many times. What do you do first?
So we'll try to collect the data
Consult with the customer.
from the customer.
Customer
Yeah,
and
you
ask
go
for
back to
the
your customer
data
and
which
ask
is
for the
missing.
missing data, na?
Yes.
Yes, sir. Yes, sir.
Okay, so we are all technicians and technical people, and we all always like to write our own functions, right? So, but when you are a consultant in a project, your mind, your state of mind should be more consultative rather than technical. Technical will come later, but you need to first understand the data, and interaction with the client is very, very important, right? So yes, so we are talking about some null values. Very good. So in this case, assuming you'll go back to the client will say either he'll give you the missing values, so you are good, or other way say, okay, I don't have the missing values, you come out with some this, and that's where you do your interpolation or extrapolation, whatever you may call it, or you write your own function. So in this case, what I'm going to do is that I'm going to take the mean of the salary and replace it in the missing value, and I take the mean of the age and put in the missing value, the simple value. Okay.
Excuse me, sir. Sorry to interrupt, but can I
Yeah.
ask one question? Sir,
Sure.
here you have taken data set which is having very small number of values. But what if, in the real environment, we do not work with such a small data set. We work with huge data set, which is
Right.
coming here from here and there in scattered way. So, will it be possible for any company even to give such null values instantly?
Typically, you will not get null values, but whenever you get some data, you as a data scientist need to ascertain the quality of the data. You cannot leave it to the customer to decide the quality of the data.
Yeah.
Because you have to come out with the model, you are responsible to come out with the model. You need to get good data, no?
Yeah.
So you need to ensure that you need to get the right data. You may get the best of data from the client, but it may not be the most optimal, or it may not be the correct data. Though the client is responsible for the data, but you as a data scientist, you are responsible to ensure the accuracy of the data. Because ultimately, if your model fails, there's a problem, no?
Yeah, definitely. So at last, for filling the more accurate data, we need to follow some different approach, maybe.
Yeah, so that's what I'm saying. So one is you go to the client and get the data. Or the other option is if the client is not having the data, then you write some functions based on your past experience. Okay, now if you know this, that you know age and salary are always linear. So if you have a missing data, you can always take the mean and put the value, right?
Okay, thank you, sir.
So what I'm going to do here is, okay, now before that, I need to assign my independent variable and dependent. So X is an independent variable, that's our notation, and Y is a dependent variable, that's a notation. And typically, these are case sensitive. So capital X, small x, capital Y has different meanings. So please be very careful when you use the cases, okay? And if I now see the value of X, I'm not getting into what this decides, okay? I just segregated age, salary, and country as my independent variable. And my dependent variable is my yes or no, right? Now, what I'm doing here, this is the function I've written where I'm going to use a strategy mean wherever the values are null and replace it by the mean. Okay, so I'm going to take this and see the value of X. So my x now becomes, if I see the value of x, my value of x now becomes, if you see the, now it is showing you 67.7 and so on, right? So it has filled up the missing values. This is one of the examples. Then we could have various such examples, and as part of your exploratory data analysis, when you do as part of data preparation phase, you will do all sort of analysis, find out the mean, standard deviation, find out the outliers. I don't know if you have heard of the interquartile range, which is a deviation from the mean. And I always urge all my students or my faculties that to pursue a career in data science, you need to have a very strong statistical foundation. If you don't know statistics, you will not be successful as a data scientist. So your statistical knowledge is very, very important. Okay, so that's what I always tell everybody. And unfortunately, most of the machine learning workshops that happen, statistics, as a curriculum, it is not included. Many of the college curriculum, unfortunately, today. And today, and there's a lot of need, and there's a lot of need for doing statistics before getting to machine learning. That's just something which we should all know about. Now, once I've done this, now one of the important things in data pre-processing is that in machine learning, they don't understand text. If you enter some text for machine learning model, it will fail. So you need to convert any text into a number, any form of a number. And that process is called data categorization. Okay. So what happens is, if you have a France, Germany, these are the text values, and you have purchased yes or no, you need to convert this into values, which is binary values. Okay. Now, so typically what happens, there are some code available. So what happens? Suppose I have got France, US, and say Germany in my data set. Okay. I'm assuming 3 unique countries. So what I need to do is I need to convert this into 3 things. First, I will convert it into a serial number in sequence 0, 1, and 2. Okay. And then I will create an array of 3 variables. And this array will be like this. So if it is France, it will be represented by say 1, 0, 0. If it is US, it will be represented by 0, 1, 0. And if it is Germany, it will be represented by 0, 0, 1. So what I'm doing is, instead of the country, I'm building an array of number of elements depending on the number of unique countries, where the presence of that particular value 1 means that value exists. And so this is called a sparse array. So you will have one value 1, others are zeros. It's called a sparse matrix, S-P-A-R-S-E, sparse matrix. And these variables are called dummy variables in machine learning terms. So this is something which you need to do. So this is a function called label encoder in Python, which does this. Encoder, and to create a dummy area of 3 dummy variables, it is called one hot encoder. These are the very popular libraries in Python. So I will show it to you. How is this clear to all? What is this doing?
Yes, sir.
Is this clear?
Yes, sir. Yes, sir.
Okay, so let us go to our script and try to execute it. Now what I'll do is, this is my data set. So I will take this. I will first do the label encoder first. Okay. Now if I see the value of X, see my values of France, Germany, France has got into by 0, 1, and 2. Now you don't have to really, I'm just explaining the concept, but otherwise the function itself takes care of it. You don't have to bother whether 0 is France, 1 is this, or 2 is this. You don't have to bother about that. There are functions taking care of that. Now when I execute the second part, which is the one hot encoder, where what it does is, where it actually creates an array. Now if you see X now, you see here 1, 0, 0, 0, 1, 0, 0, 1, 0. So it creates an array of 3 dummy variables, and then you have the age and salary. So initially you had got 3 columns, now you have got 5 columns. Initially you had 3 columns, now you have got 5 columns. So now you have got array of 10 rows and 5 columns. Okay. So this is called data categorization. The next thing which I have to do, now I have to also do the categorization of my purchase field, because no and yes is also not understood. Okay, no and yes is also not understood. So I need to convert it.
नहीं अभी नेट आपने हटाया क्या?
Administrator, can you please put the person on mute?
मैं क्या जानूँ टूल कहाँ है?
Hello.
Yeah,
All of you mute. Participants,
not
all
speaking,
of you
please mute yourself, please. It creates disturbance in the flow.
Just
Thank you.
Minute, sir. Just a minute, I will check.
It's okay,
Sir,
sir.
I have a query before you move forward.
Sure, sure.
So this is related to this label encoder. Now, when we are when we have a nominal data like France, Germany, or any other country, 0, 1, 2 doesn't matter, right? But how do I get whether this label encoder has labeled France as 0, Germany has 1? Because what if I want to put 0 or 1 in order to predict something? So how is there a way to get that how this label encoder has coded the value? I mean the dictionary values, or how do I know which has been coded 1, 0, or 3?
Internally, it has mapped 1 to France or 0 to Germany and 3 as US. It has already done the mapping. So you are doing this for what? Is basically for the machine learning algorithm to understand your algorithm. So when you feed this data into your algorithm, it knows that this is France, this is Germany, it knows that. It has already done that internal mapping. But what you're sending to your data set, to your algorithm, is not France, Germany data, but this zeros and ones.
So then why is the number of columns increased? Because you're just replacing the values with a binary representation, right?
Correct. But then it has to know that this has to represent the countries. The value of there are 3 countries. It has to create 3 elements, which shows that okay, one is say Germany, other two are blank. Here this is France, other two are blank, and this is USA, other two are blank.
No, sir, I'm not talking about this one hat encoding. Actually, maybe I'm confused. So maybe if you can give me a little bit clarity on this label encoder once more. I mean, how exactly does the coding?
No, label encoder is very simple. It just creates serial numbers. And that label encoder function becomes an input to the one hot encoder to come out with an array. So it knows how many variables are there. So these functions work in cohesion. So label encoder will just create a serial numbers, and one hot encoder will create a dummy variables based on the number of elements. That's it. If you want to get into more into what label encoder does, that's a separate exercise. You can do it. But internally, the algorithm understands the mapping between the country and the binary numbers. Is it clear?
Yeah, okay, sir, fine. Thank you.
I think you're not convinced, but I think you
because
probably you can go through the label
question.
encoder function and see what it does.
You can think of it as either doing something which you have not coded. It's a library.
You can share this code and dataset to us. We will also try for practice.
No, I will share this code with you anyways. Don't worry.
Sure.
Yeah, but madam wanted to go into more depth of what a label encoder function is. So that is something that is not in purview of the scope.
Yes. It is full of Python. We want to go into
some more.
What I understand, sir, label encoder will automatically run the algorithm and it will code the things. That is fine. What I want to further understand is that how to go the vice versa. I mean, it has done the coding, it has encoded, it has given those things. Now I want, let's say I had 10 different names, and it has done the coding from 0 to 9.
Correct.
Now what was coded 8? In case I have simply run the code, so it would have certainly coded some variable as 8. Right. Okay. So if I want to know what has been coded as number 8, So how
But
do
why
I
do you
know?
want to do that? I mean, you can do that. I mean, if you know the function, label encoder function,
Yeah.
and if you know what the function does, you can do that. I mean, there should be a way to do that. I'm not really got into that. But why will you do that?
No,
Why
I
do you
just
want
had
to
a
do it?
query. Now, what if I want to do that? What if I want
Then
to
you
know
can
that?
use the original data set and do the query, no?
That though I can do, right? That way though I can do.
Right? You already have the data set, you can do query on that. Why we are doing this? Because the machine learning algorithm doesn't understand text.
Okay.
Otherwise, you
Sir.
can always do the query on the original data set. Nobody's stopping you, right?
Right.
Okay.
Okay. Thank you, sir.
Now, coming back. So now we talked about the data characterization. Now we are going to do a data split. Okay, before that, sorry. I have to convert this values into 0 and 1. Now, in this case, I don't have to do one hot encoder because I have to have only two values, 0 and 1. So I will just use label encoder to convert this into 0 and 1. So I will use this function to convert this into 0 and 1. Now, if I see value of y, value which was yes or no is now become 0 and 1. So you have converted into numeric. Now, all your values are numeric. So you've taken care of that problem. The next thing you have to do is to convert it into or split it into a training and test set, right? This is the example where we are using. We use a library called scikit-learn, which is one of the very important libraries in Python. And here I'm using, and what happens is here I'll create four variables: xtrain, xtest, ytrain, ytest. So I will create the training set for the independent dependent variables and the test set for the independent dependent variables, right? So I will create four variables. And when you say 0.2 here means 20% is test set and 80% is training set. So out of the 10 records, I will say 8 records are going to be my training set and 2 records are test set. Now see what happens, I will execute this. Execute this, and if you see out here, you will see the array 2, 5 for x test, 8, 5 for my training set. Okay. And in the case of y test and y train, you will see that there is nothing after this because by default there is only one column. In a supervised model, you cannot have more than one dependent variable, right? So you will have only one column by default.
So can you explain this alone, the train and test alone?
So what I'm doing, I'm splitting my data into a training set and test set. We discussed that, right? We have to split the data. So I am saying 20% is test set and 80% is training set.
Okay.
So out of the 10 records, 8 records because my training test. So I've got two variables: x test for my test data, and x train is x test and x train. And similarly, I've got y test and y train. So this is my y train, dependent variable, and y test. So 8 records of training set and 2 records of test set. And somebody was asking, how do we do the split? There is a variable called random state. When I have it is 0, it takes the first top 8 records as a training and bottom 2 records as test. But I could have different random state values, and based on the random state, it will randomly pick up 8 records from the training and 2 records from the test. This is the parameter within this function which does the randomization, right? Okay. Is this clear? X test, Y test. Who has asked this question just now? Why we have done this?
Yes, sir.
Is this clear to all? X test, X train, Y train, Y test?
Yes, sir.
Yes.
Yeah.
Okay.
So we can make multiple test and train after completion of this process?
Yeah, you can try with multiple combination of tests. You can change the random state and try. You can try different combinations, yes. Okay. Or you can try test size of 25%, 35%.
The accuracy will be different.
It will not be much.
Okay.
Because it has to represent the data more or less, right? The pattern.
Yes.
So one, you do this, okay? And the last step that you have to do is what is called feature scaling. Now, what happens is that if you see here, age and salary are in different scales. And if a machine learning algorithm needs to compare or to basically draw an inference or to draw sort of a correlation between the age and the salary, it would have been very difficult if there have been different scales, because your age will be typically from say 21 to 60, but your salary could be from 10,000 to 1 crore or 10 crores, right? So you will not be able to fit that in a scale for a machine learning algorithm to do a correlation. That is where we have come out with a function called feature scaling. And that feature scaling, what it does, there are functions called standardization and normalization, right? So there are two main functions which are called standard scaler and min max scaler. Okay, these are the two library functions which are used. So what it does, it will try to bring these values to a common base scale. Now again, this is internally done, and this is again an algorithm where you may ask, okay, when I bring this down to a value, how it is mapped. Okay, this is again done using some calculation. You can again get into the depth of that function and see what it does. Okay, but there are functions available which does this scaling so that it brings it down to a common base scale. Now let me demonstrate to you. Now you have got X test, X train, which is 8 records, and you have X test, which are your 2 records, right? Now what I'm going to do is that I'm going to use these standard scaler. I can use either the min max scaler or standard scaler, both any one of them we can use, that's fine. And I will apply that on X train and X test. Now see what happens. When I apply this on X train, now see X train, and after scaling, the values will be typically between -2 to +2 or -1 to +1. See the values, -2.64, -0.774, 1.67. Then again, the question is, how do you map it? You don't have to bother. Frankly, if I'm a data scientist, I'll use this function and go ahead. But yes, if you want to go more into depth, you can find out. But this is important. Feature scaling, whenever you have very numeric values of different scales, you have to do feature scaling for optimization. You can also do it without feature scaling. You can execute the script.
Sir?
Yes, yeah.
Don't you usually scale between 0 and 1 instead of wide range?
No, it will be typically between -1 and +1. You see there are some values of -0.6 here. If you see here, you have values of -0.482. So typically values will be between -2 and +2.
So what does normal scaling do? Doesn't it normalize between 0 and 1 so that you have a proper curve?
It's not because of proper curve, because when you have a -1, so you have a range between 0 and you have a left side axis for the minus and the right hand side. That's how it is, right? So that's how it scales it, so that you will do a proper representation in the graph. Okay, so now once I've done this, so this completes my data pre-processing steps. And what I was trying to tell you is, if I don't do the feature scaling, I can also run the model. But if you see, if I try to find the accuracy with and without feature scaling will give you a higher accuracy. Okay, so that's why feature scaling is always recommended as part of a data pre-processing in any industry. You have to do it whenever you have any numeric values with different ranges. Feature scaling is required or it's recommended. Okay, as a best practice. Okay, so have you guys understood the data pre-processing part? Any questions on this? Okay. So let me go back, and I am going to execute one function. I'm going to use, there are various, these are various examples of machine learning, various industry specific, finance, healthcare, general, this, okay. You have got how to identification of ham or a spam mail, movie recommendation, chatbot, restaurant reviews using NLPs, traffic classification for self-driving cars. These are all examples of machine learning. These are all, I talked about the data preparation phase. Then the second phase is the modeling phase. Third is the model evaluation with the test data. This is the training data. This is using the test data, and then the deployment of the model. When I know that my accuracy is 90% and above, I deploy the model for the client so that he can use the model to predict for any new set of data. Okay, this is typically a project life cycle for a data science project. The various models are there. when I talk of regression, you have got univariate, multivariate regression, polynomial, decision-tree, random forest. When you talk of classification, you have got logistic regression, decision tree, random forest, k nearest neighbors, naive Bayes probability, there's a naive Bayes classifier, and you have got support vector machine. A support vector machine also has got a kernel kernel SVM, support vector matrix, depending on the linearity of the data. Okay, so these are the various algorithms which are used in the these are the most standard models which are used in the industry today, right? Now, what I'm going to do is I talk to you about data preprocessing. I will take logistic regression as one of the classification data. Okay, let me open this up. So I will do one thing. I will first.
These are all the models these are all the things algorithms we use for creating models, right, sir?
No, these are all the algorithms available. You have to use these algorithms to train your data.
So another one doubt I have yesterday that some on faculty has teached for this. For cleaning data, what are all the things we will do? Sir? What are all the algorithms? We have any algorithms for cleaning the data? Any particular algorithm?
There is no algorithm available. There are tools available. There are data cleansing tools available. There are ETL tools available. Okay, by which you can transform the data. Okay, there's an extract, transform, load data. There are various tools available to clean the data.
It is fully automated tools.
Yeah, you can use various tools. There are various tools available in the market today.
Okay.
So these are the various models. So let me focus on classification today. And if I get another opportunity for a session, I will probably cover regression. But as of now, let me focus on classification now. So what I will do is let me go to, I'll close this. I close this. I will select another folder called classification. Classification and logistic regression, right? And I go to my files, I select the folder logistic regression.py, and this is mine. Okay. This data you already know, because only thing I talked about automotive company, yeah, but the only thing I've added is the user ID, and I've got gender, age, estimated salary, and purchased. Now, if I go to the data pre-processing steps, okay, one is obviously you're going to import your libraries, you're going to import your data set. Now, you first of all, we know this is classification. Now, which is going to be your independent variables?
Estimated salary?
It depends upon the objective, what we want to achieve.
The same objective. I want to basically find out the profile of the people who are going to buy a car or not, right?
Then purchased.
Purchase will be your dependent variable. That's correct. But what about the independent variables?
Salary, age, and I think gender.
Correct. So salary, age, and gender. What about user ID?
This is the identification.
Fine,
based on male or female?
No. Gender, age, estimated salary is going to be an independent variable. What about user ID? Is that going to be an independent variable or not?
So, do we really consider this user ID for any kind of predictions?
That's what I'm asking you. If you are a data scientist, what do you do?
So we can exclude this.
Exactly. Yeah, that's what I was looking at. You don't have to bother, right? Because it's unique for every customer and there's no meaning for the analysis, right? So absolutely correct. So you don't have to take care of user ID. Now there is one thing here is that the client has also told me that you don't worry about the sex of the person. Just focus on, just omit the gender and focus on the age and estimated salary. So in that case, your age and estimated salary becomes my independent variable. Now, do you need to do data categorization for this data? Do you need to use label encoder or one hot encoder here?
No, sir. Yes, sir. I think for gender.
Gender you have to use, right?
But here
But
we are
I would
not
have
going to
used gender if it would have been included in my analysis.
then we should take care of it. Here we can
Correct. But if my gender is not, that's why I specifically said that I don't have to include my gender in my analysis, as the client has told me. So in that case, I don't have to do data categorization, but otherwise, yes, I have to do data categorization where I can convert into a 0 and 1. Right? Then what about splitting? Splitting anyway, you have to do training and test set. That is, there is nothing, no choice. You have to do the split. What about feature scaling? Is it required?
Yes, sir. For estimate salary, we need because its number is more dominating. As far as to age, I think so.
Yeah, because of different scales, you anyway have
Yeah.
you have to do the feature scaling, right? Absolutely right. So now let me do that. So let me import my libraries. I've imported my data set. I've taken my age and salary as my this one, and this is my independent variable. So if I see X here, is my age and salary, and this is my purchase, yes or no. Then I split my data into 75% training and 25% test. If I go to my variable explorer, then I've got how many? So out of 300 records, 100 records, sorry, out of 400 records, testing is 100 and training is 300, 75% and 25%, right? Then I use the standard scaler here. I use a standard scaler function. So I will see those small values. So now I've completed my data preparation stage. Now I will go to the modeling stage. So what I do in the modeling, I use an algorithm, logic regression. I feed my X train and Y train, which are my training data, and try to come out with a pattern, right? Then I do the X test. I feed my X test. Just remember, I feed my X test into the model and try come with a predicted Y. Now with Y-pred, I'll compare with what? What will I compare Y-pred with? What will I compare Y-pred with?
The Y value.
Which value?
So the actual value of the purchase, Y, which we already have defined.
So what is that?
Y value.
Everything
That
is
is
in front of you.
1 and 0, which we have
Third
converted,
value.
right?
No. Yeah. So what is the variable? What is the variable we are going to use?
X test Y.
Y-pred. You will compare with which variable?
X test.
How can you compare
Y test.
Y test? Correct.
Y test.
So I
Okay.
will compare Y-pred with Y test. Correct. So I will compare Y-pred with Y test, and to do that, I can use some metrics. And one of the things that we measure in the case of classification is called the confusion matrix. Okay. And what is the confusion matrix? I will explain. So in the confusion matrix, what you have is called a predicted value and the actual value in two axes. And in this scenario, your predicted value is 0 and 1 and actual value also 0 and 1. So you will, if this is your test set and you want to find out the accuracy, then you will have, say, 35 samples where the actual and predicted value are both zeros. There are 50 samples where the actual and predicted values are again 1. So your model is perfectly fitting or working as per the actual requirement. There are 5 cases and 10 cases where the model is giving you an inaccurate answer. Basically, the model is giving you something and the actual is something. Okay. Now, if I want to calculate the accuracy of this model, I will say simply accuracy is 35 plus 30 divided by 35 plus 50 divided by total, which is 85%. And my error rate is 15%. Okay. To make this more clear, let us come here. And I will take an example of a healthcare where plus means a person has cancer, negative means he does not have cancer, and true plus means it is the actual values, and prediction is means predicted value of y. Okay, your y is having 0 and 1. So 0 means it does not have cancer, or plus means he does have cancer, and minus means he does not have cancer. So now if you see here, this value here where we have predicted he has got cancer and actually he has got cancer, so we are good. That means it's giving the right case. So this is called true positive. Then you have here where you have predicted that he does not have cancer and actually also he does not have cancer. This is true negative. There are two scenarios where I predicted that he does not have, I predicted he has got cancer, but actually he does not have cancer. This is still okay. Okay, but it's an error, but it's a less severe error. It is called false positive. What house here? I predicted he does not have cancer, but actually he has got cancer. This is the most serious scenario. If a doctor does this wrong prediction, it will be a danger for the patient, right? If a model gives you a prediction that he does not have cancer, but actually the person is having cancer, then the doctor is not getting the proper diagnosis, right? Right? Just give me 1 minute. I'll just charge my. So if you see this case where the person has where you're actually he has cancer, but your prediction is he doesn't have cancer. This is called the true negative. So you have the false negative. So you have got true positive, true negative, false positive, and false negative. And this is very beautifully explained in this slide. So what is true positive? What I explained to you is also mentioned very clearly here. Now, is this clear to all of you? This particular slide?
Yes, sir. Yes, sir.
Yes, sir.
Okay. Now, if I want to calculate the metrics, there are 4 metrics which are used in classification. They are called classification accuracy, which I already told you, TP plus TN divided by total. Misclassification rate, also called the error rate, which is FP plus FN divided by total. Precision, which is TP, that means it says when the model predicted true, how often it was right. That means true predictions. So TP divided by TP plus FP. That is your precision. And recall is TP divided by TP plus FN. Okay. And based on this, there's another thing which is called the F1 score. F1 score is again, it's a formula based on precision and recall. It's sort of an average, right? So there's a classification report in Python. When you print the classification report, it will give you all these parameters: accuracy, error, precision, and recall. And again, as I said, your accuracy, precision, recall should be typically more than 90% for your model to be recommended to your client. And obviously, accuracy should be less than 10% or so, right? So these are the KPIs or the key performance index, key performance metrics, okay, which are used to measure the accuracy of a classification model. So you have classification accuracy, misclassification rate, you have precision, and you have recall. Now, let us go back and execute this line. So this is my line which is going to calculate the confusion matrix. So what I'm doing is I'm using y-test and y-pred and trying to find out the confusion matrix. Now, if I give CM here, it is giving me an accuracy of 89%. And if you ask me, I will never recommend this model because I would prefer at least 90%. So what happens in industry is that you will try the same data set with all the models. Now you have tried with logistic regression, you will try this with decision tree, you will try this with random forest, you will try with k nearest neighbors, you will try with SVM and so on, and find a model which gives the highest accuracy, precision, and recall. And this is how an industry works. You will never stick to one model. You will try all the different models for classification for a set of data and find out which is the one which is giving the highest accuracy or the highest metrics from a accuracy perspective. Okay, so this basically talks about how classification is used. Okay, so I mean, this is just an example. I wanted to run through this because you can understand the flow. So we talked about the data pre-processing. This is called the data modeling. Then we did modeling the data. Then this is called the outcome. That is called the model evaluation, where you test it out using confusion metrics. And if I want to plot the graph, it creates what is called so this basically, if I use the training data or these are test data, so what it shows is called a linear, is called the prediction boundary. So on the left hand side is all the people who are going to not buy the car, that is zeros, and then the right hand side are the greens, that means people are going to buy the car. So all the dots, red dots on the left are the actual data, test data. So if there are reds in red, we are good. There are greens in green, we are good. But wherever there are reds in green and greens and red, these are the false positive and false negative data, which determines the accuracy of the model. Okay, so this completes my session based on whatever I have today. So I basically covered machine learning concepts, I covered data pre-processing, supervised model, and showed you how data pre-processing and classification is one of the models of classification which I've demonstrated using Python. Any questions? Have you guys enjoyed the session?
Yes, sir.
Yes, sir.
Yes, sir.
Have you guys
Yes, sir. Yes.
learned something?
Yes, sir.
Yes, sir.
Yes, definitely.
Okay, any questions before we wind up?
Sir, can you share your code?
Yeah, I will do that. Don't worry.
Yes, the PPT.
I will do it at the end of the session. I will say to Kumar sir, he will share it with all of you.
Yeah, I will share it. Any response from the participants, please? You want to say something?
Yes, sir. It was very interactive, and I have learnt a lot from this session. So I will practice this on my own, and
Yes,
it was good, sir.
Yes, yes. You have to practice. Then only it will be useful.
Yes, sir. Then it will be more clear to me once I practice it myself.
Yes, yes. Then you will get a confidence.
Yes, sir.
Anybody?
Yes, it's very interactive session, and we gained a lot of things from this. And moreover, it it gave us an overview about how the machine learning and its algorithm works. It's really very learning.
Okay, thank you.
Any other responses, please? Thank you, sir. Aranjit Chaudhary.
Okay. Thank you very much. Thank you for your time, sir. Thank you.
You spend your valuable time to clear the concept of a machine learning, supervised learning.
Yes.
Most of our participants are very happy with your interactive session. Now I will invite Ratish Raju, research scholar, to propose a vote of thanks.
Thank you, sir. Sir, am I audible?
Yes, yes, audible, Ratish.
Good morning to all. It gives me an immense pleasure to deliver a vote of thanks for this session. I think the session was very useful and interesting one, and I hope that all the participants were really enjoyed the session. Now I'm moving to my responsibility. On behalf of the Department of Computer Science, Central University of Kerala, I express my sincere thanks to our resource person, Mr. Aranjit Chaudhary, sir, for such a wonderful session. Thank you, sir.
Thank you very much. Thank you. All the best.
Then I would like to extend my sincere thanks to all the respected personalities who gathered here to make the session a success. Thank you all. Thank you very much.
Thank you very much. Bye-bye.
Thank you, sir. Thank you very much. Thank you, participants. So next session will start at 12 o'clock. Be hold. Okay, within half an hour, next session will start. You want to talk anything with me? Yesterday I shared PPTs through the group mail. I hope everybody received and
Yes, sir,
kept,
received them.
and kept in the WhatsApp also.
Yes, sir. Thank you, sir.
Okay, okay. Thank you all.
Yes, sir.
Okay.
Thank you.
Next session will start at 12 o'clock. Be on hold.
And participants, please fill that feedback form.
All of you fill the feedback form, please.